tea. The milkman, the paper boy, evening TV. Did I get delivered here? Somebody tell me please. This whole world confusing me.
Hey, I'm Jaslyn.
Hi, I'm Sarahi. Are you interested in learning the difference between solving a z-statistic or a t-statistic?
No? Well, we're gonna show you anyways.
Stay tuned.
So both are tests used to determine whether the population mean significantly differs from a hypothesized mean.
So the difference between the two tests is for a z-test, you already know the standard deviation, and for a t-test, you are not aware of the standard deviation and you have a smaller sample size. This is an example on how to solve a z-statistic. So the first step is to find the standard error. The equation for the standard error is square root of p times 1 minus p over n. In this case, p is equal to 20%, and we're going to put that into 0.2. Plug it in, 1 minus 0.2, square root, and the n is going to be the total of UCI students, which is 80. So the standard error is going to equal to 0.045. So once you have the standard error, you could go into the second step, which is finding the z-score. So to find the z-score, z is going to be observed minus expected. Observed is going to be 30% because we're observing that specific 30% out of the 80 students. So we're going to transfer 30% into 0.3 minus expected, which is 20%, which is going to be 0.2 over standard error. And our standard error is 0.045. So we just plug that in and we solve it, which is going to be 2.22. So after we find the standard error and after we find the z-statistic, we are able to find the critical value. In this case, the critical value is going to be based off of sigma, which is 0.05. So after we have 0.05, we look into our critical value table. So because our problem is asking for a two-tailed test, we're going to look at this section. And sigma is equal to 0.05. So we go down on this column, and our critical value will be 1.96. So the last step is to find the conclusion. After we find the critical value, which was 1.960, we compare it to the z-score. And once the z-score, if the z-score is more than the critical value, that means that we could reject null. And if we reject null, that means that something is happening. So that means that UCI students actually do use more scooters than an average college student. This is how you find the z-statistic.
So I'm going to show you how to define the t-statistic. So this is an example whether UCI students eat more junk food than the average American. So this example, we're going to identify the variables. So the average, which is also the null, will be 18.2. And we also have a sample of 4, and they ate 7, 33, 14, and 22 times fast food a month. So I'm going to write that and show you how it would look. So the null is 18.2. We have a sample size of 4, and they're asking for alpha, which is 0.05, and it's a two-tailed test. So in this example, they're asking us to calculate the t-statistic, state the critical value, and conclude about the null. So we're going to find the sum of squares, and in order to do that, we have to create a table. So I wrote down the samples numbers 7, 33, 14, and 22. And we first need to find the mean of the numbers. So we get 19. After we obtain 19, we have to subtract the mean from each of the individual samples. So the number would be 12, 14, 5, and 3. The second step is to square each of these numbers. So it would be 144, 196, 25, and 9. After we obtain the numbers, we have to sum these, and this will be the sum of squares. So the total would be 374. And that's how you find the sum of squares. So the third step in this example is to obtain the standard deviation. So after we have the sum of squares, we have to square root the sum over the sample size minus 1. So in this case, n minus 1, 4 minus 1 would be 3, and you get 11, 17. And this will be your standard deviation. So the fourth step is to finally find the t-statistic, and in order to find the t-statistic, we obtain the equation of observed minus expected over standard error. And this looks like this: x minus u over sigma divided by the square root of n, and n is the sample size. Sigma is the standard deviation. So when we simply have to input the numbers. So the observed in this example will be 19, because 19 is the mean of the sample. So 19, and the expected will be the null, which is 18.2. And so after we have to input the numbers for the standard error, which would be sigma, and we already calculated the standard deviation, which is 11.17, divided by the square root of n, and n is 4 because it's a sample size. And so we get a value of 0.143. And that's the t-statistic. So the fifth step is finding the critical value, and in the critical value we will use a t-chart. But first, in order to find the critical value, we need to know the degrees of freedom, and the degrees of freedom is n minus 1. N is the sample size, so 4 minus 1 is 3. So I will show you how to use a t-chart to find the critical value. So this is a t-table, and we know that this example is asking for a two-tailed, and we know alpha is 0.05, and we calculated the degrees of freedom, which is 3, so we simply follow the chart. So 3, and we look for alpha, which is 0.05, and the answer will be 3.182, and that's a critical value. So this is a critical value, and this is our t-value, and because the critical value is larger than the t-value, we're going to fail to reject our hypothesis, and we can visually see this with a normal distribution. So the c-value would be placed at 3.182, and the t would be placed somewhere along these lines, 143. And because the t-value doesn't fall in within the significance level, we're going to fail the hypothesis. So in conclusion, the t-value is 0.143, c is 3.182, and we're failing to reject the null hypothesis. So in this example, which means we cannot conclude our hypothesis of a hypothesis. You value will
T-statistic. Two tests for the z-statistic. Z-statistic. Z and t-statistic is that you